Now let's talk about another aspect of the reflection coefficient that's not used quite as often. Instead of modeling this as a magnitude and a phase, we can write our reflection coefficient as having a real part and an imaginary part. In fact, when we had our open circuit case, remember that our reflection coefficient was 1. That's the same thing as 1 plus J0. When we had our short circuit case, the reflection coefficient was -1. That is the same thing as -1 plus J0. And when we had our matched case, the reflection coefficient was 0, which is 0 plus J0. So let's draw each of those on this graph. On top of the Smith chart graph, we can imagine having one axis which has the real part of the reflection coefficient, and another axis which goes through 90, up and down, straight up and down like this, that has the imaginary part of the reflection coefficient. So if we wanted to plot the first one, the open circuit, where our real part is 1, we're going to go right down here on the real part equals 1 axis, right there to this point. That's the open circuit case. Now when the real part is -1, we're right over here, same point that we were before. That's the short circuit case. If we want to look at the real part being 0 and the imaginary part being 0, that's right here at the center. That is matched. So let's go back and look at a few of our other cases. Let's suppose that we wanted to have a real part of a half, that's about right here, and an imaginary part of a half like this. That would give us a point going through right here. Let's call this point D. Well, let's find out what the reflection coefficient of D happens to be. First, let's look at its phase. Remember, we're looking right out here. That looks like that's 45 degrees. And let's look at its magnitude. We need to find this magnitude, so take your piece of paper and mark right there what the magnitude is. Bring it down here at the bottom, mark the center point, and then mark its edge, just like that. Looks like the magnitude is about 0.78. So, point number D, the reflection coefficient at D, has a magnitude of 0.78 and a phase of 45 degrees. Remember these special cases, our open circuit, our matched case, and our short circuit case, because they show up routinely. Remember I told you the Smith chart is often used for being able to calculate or being able to observe measurement data. So this matching point right there, that special matching point, is one that we're always watching for, and we recognize our open circuits and short circuits. So remember those points. Those are very important.